Hello, this is Seth Gleason, and a couple days ago I went and toured the substation at Dunklin and Clark Street, and I took a bunch of photos, and this is what I found. So at the edge of the street, there are a bunch of pull-top single transformers, and as you can see, right about here, these transformers. Um, they're suspended at the top of riser poles, which is really important, and they are characterized by their small volume and their very easy installation, and also they're highly efficient. And according to the Scotech website, these transformers are rated for up to 167 kilo K. I'm sorry, they are rated up for 167 kVA and a primary voltage of up to 13.8 kV. Another type of transformer that is commonly found at these substations are the pull-top bank of the three single-phase transformers. So like previously on the previous slide we saw one single-phase transformer, but sometimes there are three transformers, as you can see right here. And these having three transformers is very useful because it makes the system more efficient and economical, because three-phase systems are they're just more efficient because they can hold power better. And these transformers take in a high voltage and can either step up or step down the voltage as well. And a bank of three single-phase transformers can be useful, but it's not necessary because a single three-phase transformer can work well. But a lot of the times, companies like to put in these three single-phase transformers because they are small and easily installable. Also, if one of the transformer breaks, the bank can be used as an open delta transformer. And the substation I went to didn't actually have a single three-phase. I'm sorry, they didn't have a three single-phase transformer, so I had to find one from the internet. But it's right there. Another type of transformer that is easily found at a substation like the one I went to is a pad mount transformer. And these transformers are very useful because they can be placed anywhere, since they are locked in a steel box, and they're also usually on top of a big slab of concrete. So because they're locked in a steel box, they don't have to be installed in areas that need fencing. But in our case, it was installed in an area with fencing because it was just inside the substation. But these transformers are connected to underground distribution lines to help step up and step down the voltage, because there is a ton of voltage and power in these transformers. And these transformers are usually manufactured in power ratings of up from 75 to 5,000 kVA, which can make them very, very powerful. Another thing that is commonly found in a substation is the fuse cutout. And the fuse cutout is really important because it's the combination of a fuse and a switch, and it protects the transformer from current surges and overloads. And like if an overload happens, the fuse will melt and the mechanism will open. Like right here, it will open and it will swing on this hinge. I took this photo, but here's a clearer photo. Like there's a hinge right there, and this part will open up and swing down. And after that, that makes it so the power system and electronics can be saved from a huge surge. And yeah, it consists of three major components: the cutout body, the fuse holder, and then also the fuse element. Another device we found at this substation is it was at the top of the poles. It was the surge arresters, and they are right here. And these surge arresters are useful to protecting devices from surge currents, specifically lightning strikes. Because like if a lightning strike hits something, there needs to be something to divert that extreme amount of electrical energy. And thankfully, because of the properties of these surge arresters, they can help divert the lightning away from the important valuable equipment. And they do that because they contain a series of metal oxide varistor blocks that act like a voltage controlled switch. And when the voltage on these blocks increases above the reference voltage of the arrestor, the blocks go into conduction. But the conduction ends when the voltage drops below the reference voltage. So it conducts for a little bit and then just eventually stops. Another highly important device at these substations are reclosers, and a recloser is a high voltage electric switch that shuts off electric power when a short circuit happens. And they are these devices right here, these devices. And these devices are super interesting because after they trip, the recloser will automatically test the electrical line to determine the problem. And if the problem was fixed, then the recloser will reset itself and restore the electric power automatically. And this helps make sure that the people who are like working at these substations don't have to manually they don't have to manually like close these reclosers, which helps electric companies save a lot of time and money. And super cool, the first successful recloser revolutionized the protection of high voltage lines and made it possible for electric utilities to provide dependable power to customers. Another thing is our bank of capacitors. A bank of capacitors is commonly found at substations as well. And basically it's just a group of several capacitors with the same rating. And they are used to store electrical energy and help condition the flow of that energy as well. And I believe that these right here are the capacitors. I wasn't completely certain. I think it might have to do with this block as well, right here. But I believe this system is the capacitor system for that substation. And like with more capacitors, there's going to be more electrical energy or capacitive energy that can be stored in the device. And these devices are actually really useful because of the shunt capacitors. And the shunt capacitors help improve the quality of the electrical power, which in turn improves the efficiency of the entire power distribution plant, because these shunt capacitors help regulate the efficiency by incorporating power factor correction, which is super important. Another important part of the substation plant is the voltage regulator. And the voltage regulator is a system that automatically maintains a voltage within a defined range. And because of heavy loads and long electrical distribution lines that will drag down the system voltages, voltage regulators help maintain voltage levels within acceptable ranges. And power distribution companies use voltage regulating auto transformers to regulate the voltage. The auto transformer regulates the voltage by changing the tap of the output voltage. So voltage regulation is super important when it comes to substations. And lastly, another important part is the riser pole. And these poles right here are super important because they contain a lot of the important equipment, like the power lines. You see the power lines are running along them. The surge arresters right here, and then also on a lot of them they have the transformer blocks like somewhere around like this area. And these poles help isolate the electrical voltage and devices from the surrounding environments.